Hello and welcome to today's class. Let's look at yet the limit of a function of several functions. In our last class, we dealt with the limit of a function whereby you have just a variable x, right? In this case here, look at a limit of a function whereby you have the variable x, y, z, right? So let's say I'm given a limit. Let's say I'm given a function, the limit of a function x comma y. This becomes limit of two variable x, y, right? As x tends to a and y tends to b. So when it comes to limits, we have limits for several variables such as x, y, z. In this case, I have just x, y. This is for two variables. Let's just say I have the limit of function of x, y, z. This becomes three variables where x tends to a, y tends to b, and z tends to what the c. This becomes two variable and three variable problem. In our last class, we just look at when x tends to something. That's just one variable. We look at yet two variable and yet three variables. So where I have x, y or x, y, z. Just take two problems here and we'll have this concept. So let's say I have example one. Let's say I have the limit of, let's say, 3xy squared plus 2xy plus x, right? As s tends to 2, y tends to 3. So we have to find the limit of this problem. What do? It's as easy as what? Using your substitution method. Just put x and y as being 2 into the given expression. From here now, this becomes so the task here now, solution. My task is to put x as being equal to what? 2 and y as being equal to 3 into the given function. What the function here? This is 3xy squared plus 2xy plus x. In this case, anywhere you see x, put 2, y, put 3. I'll have 3 into what's x alone? That's 2. What's y? That's 3 squared plus, this is 2 into what's x there? 2. What's y? Of course 3 plus what's x there? That's 2. From here, I'll try to evaluate here. This is 6 into 9 plus 2 times 2, 4 times 3, that's 12 plus 2. Please help me punch. What's 9? 6 times 9. From here, what do I have? 54. Okay, 6 times 9 I give 54. 54 plus 12 plus what there? 2. If I have to add this, I'll have 66 plus 2. This will give about what there? 68. Right? So on evaluating this problem here, I have 68. So the task is quite easy. When it comes to two variables x, y, just put a value into the function. That's all. Similarly, when it comes to three variable x, y, z, put the value of x, y, z into the function. This is example 1 for case 1. Let's take one last example and we'll end this concept of several variables. So let's say I have the limit, right, of x, y, z plus xy squared all over 2xy, where x tends to 1, y tends to 2, and z tends to let's say 3. So in this case here, it's as easy as putting the values here into the given function. That's all. So solution, just put your values into the given function. From here, I'll have that I'm given the function, perhaps put x as being equal to 1 and y has been equal to 2 and z has been equal to 3 into the given function. Function is given as xyz plus xy squared all over 2xy. What's your value? What's x there? That's 1, right? Into what's your y? That's 2. Into what's z? That's 3. Plus what's x here? That's 1, right? Into what's y squared? That becomes 2 squared all over 2 into what's x there? 1 into what's y? That's 2. If I'm to solve this using mathematical concept, I shall have 1 times 2 is 2 times 3 is 6 plus 1 times 2 squared is of course 4. This is 4 all over 2 times 1 is 2 times 2 is 4. This gives what there? 10 over 4. I can't leave my answer, although it's correct, but I have to what? Break it down. So we know 2 in 10 is what? 5 over 2 in 4 is what? 2. So my answer on evaluating this problem becomes what there? 5 over 2. This is how to solve problem under limit of a function of several variables such as y, z, x, y, z per se. So this is how to solve problems of this nature.